All right, Algebra 2. We are going to be solving log equations in this lesson, Unit 7.5. Let's see, so there's three different kinds of log equations that you have to know how to solve. And so I broke them down, and so you'll see a number 1, number 2, and number 3, so three types. So the first type is the most simple. There's only one log in the problem. All right, so you can see in the question, like number 1, you can only see one log in the problem. So the first thing we want to do is isolate the log. So that means if there's a number being multiplied in front, or added or subtracted in front, or added or subtracted to the end of the log, then you got to bring all that stuff over to the other side. Okay, then once we isolate the log, then we can change to exponential form. All right, so again, you want to make sure that you remember changing forms from log form into exponential form. So on number 1, the log's already isolated. There's nothing in front being multiplied to the log, so we're going to go straight to exponential form. So first thing we do is we write the base. So this is 3, and then we raise it to the 8th power equals x minus 2. Okay, so remember, write the base, and then you switch the two terms across the equal sign. All right, so then we still have to solve for x, and then we can multiply that 3 to the 8th power out, and so we can use our calculator. 3 to the 8th, that's 6561. And we'll add 2, and so we'll get x equals 6563. All right. And then with log equations, we do have to check our answers. Not necessarily that we did it right. I mean, that's obviously something that you want to do. But what we're doing is we're checking to see if our x value results in a number that's next to the log that turns negative or 0. All right. So remember, you can't take the log of a negative number. It's undefined. And so if we put 6,563 in for x, subtract 2, we're going to get 6,561. As long as it stays positive, then we can use that answer. If it ever turned negative in that location or went to 0, then we can't use it and we would have like no solution. All right, so number 2, we have a 2 being multiplied to the log, and so the first thing we have to do is divide both sides by 2. So we get log 4x equals 3. All right, so we've isolated the log, and now we want to change to exponential form. And so remember, the base gets written first, and in this case, there is no base written, so we have to remember it's an automatic 10. So that's 10 to the third equals 4x. And at 10 to the third, that's 1,000. We can divide by 4. All right, we want to simplify our fractions. And so we get 250. All right, so again, we're just checking to make sure that the number that we get doesn't ever turn negative in that location. And 4 times 250 is positive. It's positive 1,000, and so we can keep that answer. All right, number 3, natural log x plus 2 minus 1 equals 4. So the first thing here, we have that minus 1 that we have to add over to the other side. And it's good to keep the parentheses so you don't try to subtract the 2 over, because you can't break it up, because that natural log is in front of it. All right, so there's no number being multiplied in front, so now we want to change it to exponential form. And so we need to remember the base. So remember, natural log can be rewritten as log base e, so we know what the base is. So then exponential form is going to be e to the 5th power equals x plus 2. And then we're going to subtract the 2 over. So we get e to the 5th minus 2. Now, e to the 5th minus 2, that's an exact answer. But let's go ahead and find the decimal answer also. So we're going to find our E key on our calculator, and it's probably right near your natural log key. All right, so E, we're going to raise that to the 5th power, and then we're going to subtract 2. All right, and so we'll go like 2 decimal places. So 146.41. All right, so that's the decimal. All right, so that's the first kind of log equation. All right, so the second kind is when there's one log on each side of the equal sign. Okay, so you have a log equaling a log. So in this case, what we can do is drop the logs. Okay, so kind of like when we did exponential equations, when the bases were the same, we were allowed to drop the bases and set the exponents equal. Well, when you have one log on each side, you're allowed to drop the logs or cancel them out and set the left side equal to the right side. And then we could just subtract x to get x equals 3. Again, we want to check and just make sure that we get a positive number in that location. 3 plus 4 is 7, and it stays positive. All right, number 5. We have one log equaling another log, and so we can cancel the logs out. 2x equals x minus 4. So we'll subtract the x over. X equals negative 4. All right, so again, we got to check. So if let's say I plugged it in this one, negative 4 minus 4 is negative 8. And you can't do log base 2 of negative 8. And so we can't actually use that answer. And so we're going to write no solution. All right. So remember, you can't do a negative value next to a log. So it's not necessarily that x equals a negative number. X can be a negative number as long as when you plug it back in, you get a positive number next to the log. All right, so what makes a log undefined? If the number next to the base is either negative or 0. Okay, so it can't be negative, it can't be 0. All right, so you must check your answer by plugging it back in to make sure that it is not an extraneous solution. So it's like an excluded value. All right, so number 6. We have one log equaling another log, so again, we can just cancel those out. And we can divide by negative 2. And so that x equals negative 15. So again, we have to check. If I take negative 15 and plug back in for x, is negative 2 times negative 15 positive or negative? Well, it's positive, so we can keep this answer. All right, so number 7, same thing. One log equaling another log. So 3x minus 5. 4x minus 6. Subtract. And then add 6. So x equals 1. We'll check and make sure that it works. So again, I'll just plug it into that first one. 3 times 1 is 3, minus 5 is negative 2. And so since it's a negative value, we can't use it, and so no solution. Sorry. All right, number 8. All right, we have one log equaling another log. So x squared minus 4 equals 5. So because there's an x squared in this problem, you know, a lot of times you're going to have to use factoring, but because there's no x in this problem, I can use the square root method by adding 4 to both sides. Square root. And remember, when you square root, you got to use plus or minus. All right, so our two possible choices are positive 3 and negative 3. And now we go and check and see if we can have both answers, or one or none. All right, so if I use positive 3, and I plug it in. Positive 3 squared is 9, minus 4 is positive 5. Okay, so positive 3 works. If I use negative 3 squared means positive 9. Okay, negative 3 times negative 3. Positive 9 minus 4 is also positive 5. So here I get two answers. So I'm going to keep both of them. All right, number 9. Cut off the logs. Negative 6x plus 7 equals x squared. So here I'm going to be using factoring, and so I'm going to leave the x squared on the right side because it's already positive, and I'm going to bring this negative 6x and plus 7 to the other side. So I'm going to add 6x and subtract 7 to bring them over to the right side. Alright, so now I have a trinomial, so I can use my x for factoring. Negative 7's on top, 6 on the bottom. So it is at 7 and negative 1. So x plus 7, x minus 1. And then when I set those equal to 0 and solve it, negative 7 and positive 1. And then again, I do have to check and make sure that both of them are going to work. So if I try negative 7, negative 7 times negative 6 is positive 42. Plus 7 is a positive number, 49. So negative 7 works. And then if I try positive 1, negative 6 times 1 is negative 6 plus 7 is also positive. It's a positive 1. So I can keep both answers. All right, and then case number 3, so the third kind, is when there's two logs on the same side. All right, so when you have two logs on the same side of the equal sign, you can't just cancel the logs out. Right? The two logs are going to be separated by an addition sign or a subtraction sign, and so in that case, we're going to condense it into one log, and then we'll either have case number 1 or case number 2. All right, so once we condense it into one log, we want to look. We're either going to just have one log in the problem, or we're going to have one log on each side of the equal sign, and then we can just cancel the logs out then. All right, so on number 10, two logs on the same side, we're going to condense. Addition condenses to multiplication. So it's log 4 times x plus 1 equals 2. Right, so I condensed it into a multiplication of one log. It's up to you. You could distribute the 4 in now, or you could wait. But we have it down to one log, and so now we have case number 1, where we're going to change it to exponential form. So remember the base. On this case, this problem, it's base 10. So 10 squared equals 4 times x plus 1. And then let's go ahead and just keep simplifying. We'll distribute. Okay, so don't have to get it over to that 1 also. And we'll just keep solving. So subtract the 4 over. 96. Divide by 4. So 96 divided by 4 is 24. All right. Now, again, just like all the other logs, you have to check. If I put 24 in for x right there, I just want to make sure that it ends up being positive. 24 plus 1 is 25. It's positive, so I'll keep it. All right, 11. I have two logs on the same side separated by a subtraction sign, so this is going to condense into a fraction. So natural log x minus 4 over 2. Okay, so there's my condensing. Then I'll just rewrite the right side. So now I have case number 2 where there's one log on each side, so I can cancel the logs out. So x minus 4 over 2 equals 3. Now, on this kind of a problem, I'd like to just make the right side or the other side a fraction, and then just cross multiply, okay? And then set those equal to each other. So 1 times x minus 4 is x minus 4, and then 2 times 3 is 6. Okay, so remember proportions, when you have one fraction equal another fraction. Just multiply diagonally. All right, so we'll add 4. X equals 10. Again, we want to check, and it does work. All right, 12. Two logs on the same side with an addition sign, so we're going to condense it into a multiplication. right? So we've condensed it into one log on the left side. Now we look, and we have a log on both sides, and so we have case number 2 again, so I can drop the logs. So I have x plus 3 times x plus 2 equals 2. Now on this one, I have to go ahead and distribute this x plus 3, x plus 2. I have to multiply those together. Right, so here I can distribute or FOIL. So x squared plus 2x plus 3x plus 6 equals 2. Combine my terms. Right, now I'm going to subtract the 2 over because I want it set equal to 0 so I can factor this. Right, so I need two numbers that multiply to 4 but add to 5. 4 and 1. So x plus 4, x plus 1. So x equals negative 4, and x equals negative 1. And so again, we do have to check. So if I take and plug it into one of the x's, doesn't matter which one. Negative 4 plus 3 is negative 1. And since it turned negative, I can't use negative 4. Cross that one out. If I use negative 1, negative 1 plus 3 is positive 2, and it stays positive, so I can use that one. So this one only has one answer, even though I found two of them. Negative 4 was an extraneous solution. All right, and last one, number 13. 2 logs on the left side and 2 logs on the right. So I'm going to condense the left side, and then I'm going to condense the right side. So left side, there's a subtraction, so that condenses to a fraction. Right side condenses with addition, so that turns to a multiplication. 2 times 4. I have one log on each side, so I can go ahead and cancel those out. I'm going to clean this up a little bit. 2 times 4 is 8. Make it a fraction. Cross multiply. 16 times 1 is 16. 8 times x plus 4, remember to distribute. 8x plus 32. Subtract the 32 over. Careful of your signs when you're adding, subtracting, and dividing. Alright, so I got x equals negative 2, and I'm going to check. Alright, so if I were to take it and plug it right there, negative, that's the only place that there's an x. So negative 2 plus 4 is positive 2, and so it stays positive, so I can keep that answer. Alright, and that is solving logs.